students, welcome to the class of digital signal processing. We have already studied till the properties of Z transform. We have also studied several numerical problems on Z transform. Today we are going to solve several questions on the properties of Z transform. So there are 4 or 5 questions that is mentioned here. One by one we will solve, but while solving this we will be using the properties whatever we have learned in our previous lectures. So the first question is n into a raised to the power n un. We have to find the Z transform of this using the properties. Okay, so here n into a to the power n un. What are the two things that you can, two properties which can be used here? See, this first is the unit step sequence. This is multiplied by an exponent. This is multiplied by an exponent, that is a to the power n, and then again it is multiplied by n. So there are two properties involved here, multiplication by an exponential and also multiplication by n. So let us start doing this. First un. If you have already seen my previous lectures, we have already done the Z transform of un. So the Z transform of un, it is given by 1 minus 1 by 1 minus Z inverse. You can also, in the meanwhile I am doing it over here for some of you who have not gone through those lectures. So since it is un, that is the unit step sequence, it will start from 0 and go on till infinity. Now here the first the value that it is here is you will be getting is 1 into z to the power minus n. So this will be a geometric sequence again. So we know till now that 1, then it is z to the power minus 1. This way it is going to go on. And the sum of infinite series in a infinite geometric series, it is given by a by 1 minus r. So 1 by 1 minus z to the power minus 1. And from here if we take out the ROC, z to the power minus 1 should be lesser than 1. So this comes out to be mod z greater than 1. Now this is the same thing which I have written here. This is for the ROC. Okay. So you have to understand that this is my basic signal. Now this signal is multiplied by an exponential sequence a to the power n. From the property that is multiplication by an exponent, we have learnt that the Z transform will become, see, if the Z transform of this one is this, then this Z has to be replaced by a to the power minus 1. So what we are going to do is, here we will write 1 by 1 minus a inverse Z whole to the power of minus 1 and simplify this part. Now if you simplify this part, what will you get is 1 by 1 minus this a to the power minus 1 into minus 1. So that is becoming positive 1. So it is a into z to the power minus 1. You can again you can simplify it more and then you can write it z by z minus a. Right? A by z, so z minus a, and above it goes z. Now this is the z transform of a raised to the power n un. Okay. Now the final thing is that you have to multiply it with n also. So when you have to multiply it with n, so what we will do is, I'll erase this portion where we have found the un from the basic formula, we have found it out. Just I'm erasing that part. Okay. So now we are going to multiply this with n into a to the power n un. What is the property? If the signal is multiplied by n in the time domain, then it will result in the differentiation of the signal in the z domain or the complex frequency domain. So what it will become is minus z into the differentiation of xz, right, with respect to z. Fine. Now this result is your xz. You have to differentiate this part. So the answer will be minus z. Wait a minute. So this is going to be minus z d by dz of z into z by z minus a. Just use the differentiation and write it. So this is going to be z minus a dz by dz, that is 1, then minus z, again d of z minus a with respect to dz, that will be 1, and this is z minus a whole square. So till here, now this part, z and z gets cancelled over here. Z and z gets cancelled. So what you are having is minus a here and minus z. So az by z minus a whole square. Z minus a whole square. Rewriting the answer once again. Okay. In this portion I am rubbing. This is your question. This is the question. So the answer that you have got is az by z minus a whole square. Az by z minus a whole square. This is the final z transform of this whole signal. N into a raised to the power n un. First we found out the z transform of un. Then we are multiplying it by an exponential sequence. When you multiply with the exponential sequence, the property says that whatever there is here, the place of z will be replaced by a inverse z. Whatever is the this base over here, base will be raised to the power of minus 1. So we replace this the z transform of this one, not the z of this one, with a inverse z, and then we have resimplified it. After that, you have to multiply it with n in the time domain. So that will result in the differentiation in the frequency domain. Why I have written this minus z? This when we have done the property of differentiation property proving, that time you have seen how this minus z is coming. So final answer that you are getting is az divided by z minus a whole square. Hope you have got it. Okay, the next question. Let's move on to the next question now. The next question is half into n square plus n 1 by 3 raised to the power of n minus 1 into u to the u of n minus 1. So you can see directly over here that if you are writing un, that is unit step sequence. But when you write u of n minus 1, that means the step sequence has been shifted. Okay. So the time shifting property is going to be used here. The time shifting property. Let's go ahead and solve this one. So I will not rewrite the question. I will just start from here. See, this is 1 by 3 raised to the power of n minus 1, u of n minus 1. So first, decipher this one properly. The parent signal, you can say, the parent signal for this one will be what? 1 by 3 to the power of n un. So what will be the z transform of this one? The z transform for this one will be 1 by 1 minus 1 by 3 z inverse. Right? Now, you are shifting it by time shifting by 1 unit. So this side you are time shifting by 1 unit. So in the z transform, what is going to happen? From the properties of z transform, we know that it is going to be multiplied with z to the power minus 1. The power will be equal to the times you have shifted. So you have shifted it only by 1 unit. So z to the power minus 1 divided by 1 minus 1 by 3 z inverse. Now again, how to do this one from the basic equations? Basic formula of z transform, that is already discussed in the previous classes. Now here you see, there are two signals. You can write it half n square into this part plus n into this part. Again, one linearity property is there. This plus means if I write it, see, this will be half into n square into 1 by 3 n minus 1 u of n minus 1 plus half into n, then it is what? 1 by 3 n minus 1 u n minus 1. So basically there is a plus sign over here, means we can separate it by using the linearity property. That is the same thing I have done. So we will deal with these two signals separately, this one and this one. Now here first see this one. This is having lesser values, means lesser power of n. Here it is n square, here it is only n. So this is what? Multiplication by n. So again this has to be differentiated. So this has to be differentiated, and this is just a constant. Half is just a constant. So just forget about this part right now. What we are doing is we are finding the Z transform of this part. Okay. So for finding out the Z transform of that part, half is your constant that will come out. You can write here the Z transform of this one. 1 by n into 1 by 3 n minus 1 u n minus 1. Okay. So you know the Z transform of this one. 1 by 3 into this part, you know. This is what? For this one, the Z transform is how much? Z to the power minus 1 divided by 1 minus 1 by 3 Z to the power minus 1. Now we will have to differentiate it. Right? So we will have to differentiate this portion. Let us do it here. First we will simplify it, then we will differentiate it. Let us simplify it here itself. So this is what? 1 by z divided by 1 minus 1 by 3z. This becomes 1 by z divided by 3z minus 1 by 3z. So z and z gets cancelled. So what you are having is 3 by 3z minus 1. So 3 by 3z minus 1. Now this was the Z transform, right? Yes. Now 3 by 3z minus 1 has to be differentiated. Differentiation with respect to z and multiplied with minus z. So this will be the Z transform of what? This full thing. This full thing, that is n into 1 by 3 to the power n minus 1 u of n minus 1. So first let me differentiate it, then I will write the answers directly. So what it is? Minus z. If you differentiate it, then 3z minus 1 into 0 minus 3 into 3, right? 3 will be the constant. If you differentiate this part, it is going to be 3 and 3z minus 1 whole square. So this is your differentiation. This will be equal to how much? This is 9 and minus into minus, this will be plus. So 9z by 3z minus 1 whole square. And there is a minus z over here. So that minus z will make it minus, okay, then that z I have already taken. That z is already taken over here, right? Yes. So the z is already taken. There is going to be only one z. Okay, fine. So this one was the Z transform of this whole thing, and then it is also multiplied with half. So there will be a 2 over here. Now if you want to find the Z transform of this one, then you will have to differentiate this part also, right? So differentiation of this part, because here it is half n square. Now let us do this portion. See, we have already written this portion. This part I will rewrite it over here. This is the Z transform of what? 1 by 1 by 2 into n 1 by 3 n minus 1 u of n minus 1. This is the Z transform of this one. Okay. Now simple thing is there that you have to, instead of this n, there is n square. So you have to do n square by, you have to differentiate it 2 times. That's it, nothing new. 1 by 3 n minus 1 u of n minus 1. So this is the result of differentiation one time. So we will differentiate this thing only second time also. So just do it at the side. This is minus 9 by 2. Now if you differentiate it, then 3z minus 1 whole square. Here you will get dz by dz, that is 1. Minus, again you will have this z. This one, the differentiation is going to be 2 times of 3z minus 1, right? And this one is going to be 3z minus 1 whole cube. Now one thing that you have to keep in mind over here is that when we are differentiating only with, when we are multiplying n one time, that time we had here minus z. Now this time it is going to be z square. Okay, so minus 9 by 2 z square, and this portion you will have to solve it completely. That will give you the final answer. 3z minus 1 whole square minus 6z square plus 2z divided by 3z minus 1 whole cube. You can solve it for yourself. I have made you understand the property over here. So first property was the time shifting, and then we have used the linearity property and then the differentiation property. So now let's move on to the next question. For this question, the ROC is going to be the same as that for this 1 by 3 raised to the power n minus 1 u of n minus 1, right? So what will be the ROC for this question? From the first part only you can just write it. Just I'll do the ROC once again for you. Okay. See, when you are writing the main signal itself, 1 by 3 n minus 1 u of n minus 1, that time itself you can write the Z transform of this, because after differentiation the ROC is not changing. ROC is remaining the same as the parent signal. So over here 1 by 1 minus 3 Z inverse was there, and there was one extra Z inverse. So 1 by 3 Z inverse is lesser than 1. You already know this part. So this is going to be mod Z greater than 1 by 3. And since there is 1 by Z, that is Z will not be equal to 0. You should not take Z equal to 0. So this portion Z is equal to Z not equal to 0. So that means entire this part will be there mod Z greater than 1 by 3. It will not include 0. This is your ROC for the previous question. Means this one, question number 2. And how to do it we have already done. So now let's move on to using the convolution property. So the next question is on the convolution property. If the signal is convolved in the time domain, then it will result in its multiplication in the Z domain or the complex frequency domain. Same case happens for the frequency domain also or the Fourier domain also. But right now we are doing the complex frequency domain or the Z domain. So let us do it. So first signal is x1n. This is given as 1, 2, 3 and 4. Okay. If you find the Z transform of this one, okay, you can directly write it, but I will explain you how to write it in the form of the delta signal. So if at this portion, what we can do is, we can write this x1n as, this amplitude is 1, so delta n, this position is 0. It is the starting position. When the arrow mark is not given, take the starting position as the 0th position. Now this is, the amplitude is 2 and it is shifted by 1. This is the position 1. So 2 into delta n minus 1. Then 3 into delta n minus 2. Plus 4 into delta n minus 3. So I have explained this in my previous lecture. Why we are writing n minus 1, n minus 2, n minus 3 with the delta. Okay, now the Z transform of delta n. That is also done in the previous lecture. It is what? 1. Simple thing that if you take delta n, Z to the power minus n, it exists, n is equal to minus infinity to infinity. But this n is existing only at 0, so we have nothing to do. We have to write delta 0 and Z to the power minus 0, the value is going to be 1. So the Z transform, if you write for this, it is going to be, okay, the Z transform for delta n is going to be 1. So x1 z is equal to 1 plus 2 z to the power minus 1 plus 3 z to the power minus 2 plus 4 z to the power minus 3. Keep in mind that if it is a causal sequence which is starting from 0, in that case the z will be having negative powers, and if it is not anti-causal, then in that case the z will be having positive powers. In the previous lecture also this is done. Now here what is going to happen, the ROC will be the entire Z plane except Z is equal to 0. Entire Z plane except Z equal to 0 is the ROC for this one. Now if you do the Z transform of this x2n, which is 2 minus 1, 0, 3. Again this arrow mark is not given, so the signal you can take from here. Okay. Then, or you can, just for changing the question, if I take the signal starting from here. Okay, let us take it from here. So the x2n now, it is what? x2n is 2, minus 1, 0 and 3. And this is the position of the arrow. That means this is the 0th position. That means this is the 0th position. This position is minus 1, minus 2 and minus 3. Now if you write it in the format of delta, then x to n will be what? 2 into delta n plus 3 minus 1 into delta n plus 2, then it is 0. So 0 won't affect, but still I am writing it. 0 into delta n plus 1 and 3 into delta 0. So delta 0 means delta n, that is it. So let it be over here, the value will be 1. So if you write it in the z domain now, if you take the z transform of this, what will you get? If you take the z transform of this, you are going to get 2z cube minus z to the power 2. This is 0, this will become completely 0 and this will be 3. Fine. Now what you have to do is that you have to take out the z transform of x3n. You have to find out the z transform of x3n. And what is x3n? x3n is given to us as x1n in convolution with x2n. So the question is that you have to find z transform of x3n, and x3n is equal to convolution of x1n with x2n. So what we need to do is, first we need to find out the z transform of x1n, which is x1z we have already got. Then we need to find out the z transform of x2n, which is x2z, this also we have got, and then we just need to multiply it. So this is the multiplication over here. Need to multiply it. So we have already got these two, so I'll just keep the answers over here. Here the ROC will not be including infinity. ROC will be entire z plane except infinity. Got this one? Okay. Now I will take just the results. So the first result is this one. ROC, I think you have understood. So ROC also I am rubbing over here. This ROC also it is removed. Now let us just multiply it and write it. So final x3z will be equal to x1z into x2z. Now if you multiply this, then 1 into 3, so let's go on one by one. 1 into 2z cube, that will be giving you 2z cube. Then 1 with this 1 multiplied with all of these will give you the same thing, minus z square plus 3. Now this 2 to the power z minus 1, 2 into z to the power minus 1. If it is multiplied with this, how much will you get? 4 minus 1 plus 3. That will give you 2. Then 2z to the power minus 1 multiplied with this one will give you minus, this will be minus 2 z square minus 1, that will give you z1. Then here again it is multiplied, then 6 z to the power minus 1. Okay. Now this 3z to the power minus 2 multiply with each of them. Then in that case 3 into 2 6 and 3 minus 2 1. Then again this one with this one, then it will give you how much? Minus 3 z square is to minus 2 plus 2 will become 1. So that is 1 over here, and 3z to the power minus 2 multiplied with this one will, with this 3 will give you 9z to the power minus 2. Final, that 4z to the power minus 3, if you multiply with this one, 8 you will get here, plus 3 minus 3 will become 0. Now 4z to the power minus 3 and this is z square, so that will become minus 4 z to the power minus 1, and this last one is going to be 12 z to the power minus 3. Now after this you need to just add the same terms, right? So you can do that portion, right? this one 4z square minus 1. This one was 4z square. So this square, whatever the power is, wherever the power is square, add them all. This way you have to find out the final answer. Okay. Now the last question for today, determine xn whose z transform is xz is equal to log of 1 minus az to the power minus 1. Okay. Till now we have done convolution property, then we did the differentiation, time shifting and linearity property, right? And also multiplication by n exponential sequence. All these properties we discussed. Now this last question is a bit different. Here you need to find out xn. Now finding xn when x of z is given, that is called the inverse z transform, which we will start in our next class. But this question can be done without explicitly using all the methods of finding the inverse z transform. So what it is given here is x of z is equal to log of 1 minus a z to the power of minus 1. What we will do is first we will differentiate it with respect to z. When you differentiate this side, 1 by 1 minus a z inverse you will get, and then again you are differentiating d of 1 minus a z inverse with respect to dz. So this part comes over here 1 by 1 minus a z to the power minus 1, and this portion will be minus a z to the power minus 2. Okay, minus 1 into z to the power minus 1 minus 2. That makes it minus z to the power minus 2. Okay. Now you see over here, this part is d of xz with respect to dz. If you multiply both the side with minus z, this side and this side, both you are multiplying with minus z. So what will you get? Why are we multiplying with minus z? Because we know that if you multiply in the time domain with n, then differentiation with z in the frequency domain, and also you have to multiply this minus z. Now it will come to what? 1 by 1 minus a z to the power minus 1 into minus a. This is minus 2 and this is plus 1. So that will give you how much? Z to the power minus 1. Fine. Now this part over here, this part, this is what? This is the z transform of a n u n. This portion, if you multiply with z to the power minus 1, that is z to the power minus 1 divided by 1 minus a z to the power minus 1. If you write it in this manner, then here it is a time shifting by 1 unit. So it becomes a to the power n minus 1 u of n minus 1. Getting it? So finally what I can write over here is that this portion completely is going to become minus a into a to the power n minus 1 u of n minus 1. Got it? And this side, this is the z transform, that means you are multiplying it with what? This portion completely we are doing it, right? So this is minus z into d of xz with respect to dz. Finally what we will get is, this is the power of 1, so what you can get is a to the power n u of n minus 1. Okay. Now in this side, since you are differentiating this side, so what we have to write is, you are going to, by differentiating n into xn, when you do it in this manner, n into xn, that time you have this minus z into d of xz with respect to dz, right? So this portion is coming from the differentiation part. So what we can do over here is, we will multiply it with n. So what is my signal that we have to get it? The signal is coming out to be how much? You have to just divide this by n. Because see, here this part, over here is n into xn, z transform of n into xn is giving you minus of z d of xz with respect to dz. Fine. Now here we already got, by doing this much, we have already got what? This part, minus a raised to the power of n u of n minus 1. So this n over here needs you need to find out what is xn, so that means you have to divide it here by n, then you have got what is xn. So this is all for today. We will do the next questions, or we will do the inverse Z transform in the next class.